Now we're going to go over scaling and reflections. And so scaling and reflection is another type of thing that we can be doing, and I included them together because they're based off of the same thing. And so we're given the same equation and same thing in vertex form, but know that because this number a here is the same in vertex form, standard form, and intercept form, it's going to apply to all three of them. Scaling in the graph makes it stretch or squish vertically. So what we're basically going to do is, instead of being like our nice perfect parabola, it might be really skinny parabola, or it might be a really wide parabola. If a is greater than 1, then the graph stretches vertically and it gets skinnier. It's because each individual step is actually going to be more. If a is less than 1, then the graph squishes. It's going to get wider. And we're still with the same thing. Reflections change if it's going to open up or down, or basically it changes its concavity. You're just flipping it across the x-axis. If a is positive, then the graph is concave up. If a is negative, then the graph is concave down. So here's our parent function, and with a click of a button, I don't have to graph it because it just did it for us. And what we're going to do is we're going to transform these, and you notice that it has it in the a, so if we were to go f of x is equal to a x minus h plus k, I should really just copy paste that every time, but oh well. So what we're going to do is our a value here is going to change how much we stretch or squish it. So with 2x squared, we're going to end up starting at the same value, or our vertex is going to be the same, because you plug in 0 times anything is still 0. Now, what's going to be interesting is if we plug in, say, 1, we're going to get 1 squared, which is 1, but now that's times 2 because we had that 2 in the front. And you'll notice that that's actually double of what was over here. So with our parent function, we plugged in 1 and we got out a 1. Here, let's plug in a 2 and we're going to get out a 4. I'm going to leave you to do the math, but we're going to end up with 8. And so you notice it gets a little bit skinnier since our a value is greater than 1. Since our a value is greater than 1, it ends up getting skinnier. Now let's look at our 1/2 x squared, our green function. We plug in 0, we still get 0. If we plug in 1, we're going to get a half. So you notice that x actually, so our a value, since the half actually cuts it down in half, so it would have been a 1, now it's at a half. Here it's at a 4, so we should expect it to get down to a 2. And what's going to happen here? It's going to get really kind of wider. It still has the same shape. It's just a little bit wider than it was before. It takes longer to get to the same number. Now, we're going to do it here. We have a negative x squared. So, same thing. 0, 0 is going to be the same thing. We plug in a 1, we're going to have 1 squared, which is 1, but there's that negative in front of that. So, it's going to flip it upside down. We plug in a 2, we're going to get a 4, but now it's negative 4. And we're going to draw it. Oh, that was bad. One more time. And it basically just looks like we have a mirror here, and that we just flipped our equation across that mirror. And now we're going to do it with this one. So we're both upside down and we're stretching it out by 3. So 0, 0 is going to be the same, but now we're going to jump down to 3 for our first step. And then we're going to go down to 9. No, we're going to be really big. It'll be 12, because we're going to have 2 squared, which is 4 times 3, which is 12. And you notice that it gets really skinny really fast. So it's both upside down and it's gotten skinnier because of that negative 3 in front of the x squared. Now we're going to do the magical one that's combining everything. So first off, let's write our function over here. F of x is equal to a times x minus h plus k. So this is what we're using here. Our a is negative 2. So it's going to be concave down, so we're going to draw it like this. And it's going to be 2 times, so it's going to be skinnier. Our vertex has been moved, and it's been moved over to the right 3 and up 2. So we're going to go over 3, 1, 2, 3, up 2, 1, 2. And it's going to be upside down, so we're going to go this way. Loop. If we're to plug in numbers, what's going to happen? Remember, it's double of what it was, so normally it would be here. But it's not going to be there. It's going to be double of that, so it's going to be down to the 2. And normally, since it would have been like a 4 coming out, what's going to happen is we're going to be 1, 2, 3, 4, 5, 6, 7, 8. We're going to be at an 8 for our next point. Oh no. 8 at our next point. And draw it in. It really wants to move on to the next page. And there's our graph. So we were able to take a graph and transform it and graph it without even doing any of that actual extra work, just because of the fact that we knew that it was being moved around by these certain things. And here we're going to do the same quick check as we did before. We're going to describe the transformation in words. You notice that they get a little bit harder each time. That's exactly the way that you need to do it. If it's not a little bit of a struggle, it's not actually helping you learn. And some final words of encouragement. Remember that math is all about patterns. And I don't think you're going to get a lot of people that are going to say this, but if you can find a pattern, it means that you can cheat. And by cheating, I mean you can exploit it. So if you go back here, you notice the fact that our pattern is that as if there's a positive in front of it, it's concave up. If it's negative, then it's concave down. That's a pattern. It's a cheat. Go ahead and exploit it. And the more that you practice with the graphing, the more patterns you find and the easier it becomes. It becomes really natural. And so while 10 problems right now might take you 30 minutes, if you keep practicing and making up graphs and graphing them and seeing what happens, eventually it'll get to the point where you can just chug them all out and it'll be perfect. And basically, all I'm saying here is just keep it up. Keep the struggle going. You'll be fine. And that's it for transformations.